Hi folks, we're talking about free fall today. And free fall by definition is when you fall under the influence of only weight. No air resistance and you can't put rockets on yourself. So that's free fall. Now the equations for free fall is V0 times t minus 1/2 gt squared tells you your displacement, and v equals v0 minus gt tells you your velocity. Those are the basic equations. Let's look at an example. Dropping an object with no initial velocity. Now in this particular example, we're going to drop an object and it's going to be going originally at no velocity. Now, in the first instance, it's going to have a 10 meter per second velocity. So as it falls and reaches that first second of time, it will obtain a negative 10 meters per second velocity, which means it's going down, and will have fallen only 5 meters from the original 80 meters. So it's now at 75 meters. Now that's important to note. If you go back and look at the equations, and if we use acceleration of gravity to be 10, then that's how those numbers come out. Try them yourself. Now in the next second, we're going to obtain a total displacement from starting position of negative 20 meters, which means we start at 80, so we end up being at 60. So our displacement was negative 20, and our velocity is also negative 20. Now by the third second, we obtain a displacement of 80 minus 35. Okay, that's 45 meters. Now that's 5 meters on the first displacement, 15 meters on the next displacement between the two, and then another 25 meters. There's a pattern there. Now the last one, 4 seconds, the time it takes to hit the ground, it will have had a total displacement of 80 meters. And that's a negative 80 meters because it's going down. Now, key things to note is that's the entire 80 meters in 4 seconds. Now, the velocities, you'll notice, they go an increasing speed of 10 meters per second every second. Now, let's take a look at throwing an object with a positive initial velocity, meaning something thrown in the air. In this case, it's 30 meters per second, and it starts off at an initial position of 35 meters. Now what you see is the object goes up in the air, comes to a stop, and then falls back down. And we're allowing our object to actually fall past its starting point. So let's discuss this as it goes up. It was at 30 meters per second, and it'll slow to 20 meters per second in the first second. And it will go, now here's the weird part, it was 60, or it was 35, now it's 60, so that's 25 meters. Now in the next second, it's going to approach 75 meters. Now it's not going as far because it's actually going slower because now it's going in 10 meters per second. And in the next second, it actually doesn't go that far, only 5 more meters. Now in the 3 seconds is all it took to get to the top. It was 30 meters per second and all it took was 3 seconds to get to 0. Now after that, on the next second, it's going to be going down, or negative 10 meters per second. And it's going to be back at 75 meters, or it will have fallen 5 meters. In this case, it's kind of like the free fall where it just dropped. Now in the next second, it's going to fall an additional 15 meters from those 5 meters, a total of 20 meters. We were at 80 at the very highest point, and now we're at 60 meters again. Now in the next second, it's going to wind up falling back to its original position. Now that means the total time of flight in this case is going to be from throwing it up to getting back to your original position 6 seconds. 3 seconds up and 3 seconds down. Now if it's allowed to continue to fall for an additional second, it's going to fall the remaining 35 meters in that additional second. Now that gives us the total displacement, this is the crazy part, of only a negative 35 meters. Even though it went way up in the air and came back down, the total displacement is only negative 35. Now, throwing an object with a negative initial vertical velocity, if I can say that right. Now here's the deal. We're going to throw our object from a height of 80 meters and let it be thrown downwards. Now it's being thrown down with an initial velocity of negative 30 meters per second. Now you'll notice it really won't take it that long. In fact, a grand total of 2 seconds to reach the bottom. Now here's the main reason why. It's already moving at negative 30 meters per second. And in 2 seconds, that'll go 60 meters. And if you think about how far gravity will fall in 2 seconds, that's actually 20 meters. Put those together, you get a full total 80 meters of displacement. And that's with the object being thrown downward. Now you notice the displacements on all of the 3 examples I gave you is getting bigger and bigger as time goes on. Now, that's if for an object that's falling. Now in the case of the object that's thrown up in the air, the displacements got smaller and smaller until it reached a point where it's not going up anymore, meaning 0 velocity. Now that was the example of an object that was being thrown down. Now, take a look at these numbers and try to match up what's going on with the equations that was presented at the beginning. And that's the end of the video, as you can tell by the black screen. Bye!